Okay, so in this question, they have given the x coordinates and the y coordinates of the point with respect to time, and yeah, the point is basically moving in the xy plane. So here a and omega are positive constants. So first of all, we need to find out the distance s traversed by the point during the time tau and the angle between the point's velocity and acceleration vectors. Alright, first of all, distance traversed by the point. Alright, so for the distance we need to know the trajectory or the path basically that the point is following. For displacement, we can directly integrate the velocity with respect to time in each direction. We'll get the displacement in the x and y directions. But for distance, we need to know the exact path that the point is moving through. So let's see. Um, so one observation to be made here is you have sine omega t, you have cos omega t. And if you want to represent y in terms of x, you need to remove the terms which have t. So if we can remove sine omega t and cos omega t, we can basically write y in terms of x. So one way to do it is, let's first of all write x is equal to a sine omega t, right? The term with the t is x by a, which is sine omega t. This is one, and second is y is equal to a into 1 minus cos omega t. Alright, so this means cos omega t is equal to 1 minus y by a, right? Just divide both sides by a and cos omega t comes this side, 1 minus y by a. Alright, now from the trigonometric identity you already know that sine square omega t plus cos square omega t is equal to 1, right? This means x by a, x by a whole square plus 1 minus y by a whole square equal to 1, right? You multiply both sides by a square, multiply both sides by a square, this becomes x square. A minus y whole square is equal to a square, and a minus y whole square is same as y minus a whole square, and you can also write it as x minus 0 whole square y minus a whole square. Take a root, I'll tell you the reason why. So you'll get, since a is positive, right, so this becomes a. So what this means is the distance is the Euclidean distance formula, right, between x comma y, right, and 0 comma a is equal to a, which is a constant. Now we know that basically this trajectory of a distance, I mean if the distance of a point from a fixed, from another, like distance of a moving point from a fixed point is constant, it's basically it is traveling in a circular path, right? Yeah, so if you were to plot it, it will be something like this trajectory basically. So x, this is the y, okay, the center, I mean the center would be 0 comma a, right, and it will be something like this, the radius equal to a, right? This will be the trajectory. So now okay, so this was basically to show you that the what is the path. All right, okay, now and one more thing, we also need to see like how is the speed varying. Distance is equal to, like, speed into time, is speed is constant, of course. So let's see like what is the magnitude of velocity, right? The magnitude of velocity. So we already know x is a sine omega t. So vx, sorry, so vx is equal to dx by dt, which means d by dt of a sine omega t right? This becomes a omega cos omega t, right? Vy is equal to dy by dt, dy by dt, d by dt of a into 1 minus cos omega t, right? So you can take a out, which is a constant, and you know that if you differentiate cos, it becomes minus sign. There's also already a negative sign, so it becomes again positive, so it becomes a omega sine omega t, right? What is the magnitude of velocity? So it becomes root over vx square plus vy square, right? This is nothing but a square omega square cos square omega t plus sin square omega t, right? So cos square omega t plus sin square omega t, this is in brackets, this becomes 1 root over a square omega square, a and omega both are positive, so it becomes a omega. So v is equal to a omega, which is a constant. Basically what this means is the point is traveling in the circular path with a constant velocity magnitude, or we can say in this case constant speed. And we know that for a constant speed, distance is equal to speed into time, right? So speed is a omega, is the velocity magnitude, and the time, as they have stated in the question, during the time tau. So in this duration tau, right? So a omega tau. So this is the distance. Done. First part is done. Now second part is the angle between find the angle between the points velocity and acceleration vectors. Fine. Okay. Now this second part, sorry, just a second. Yeah. So this second part is the outcome of the second part, or the answer that we get in the second part is a very important sort of thing that you can maybe also remember. So we'll come to that. So we already have, we'll solve it the normal way and we'll come to a conclusion. So we already have vx and vy. So your acceleration will, like, wx will be equal to dvx by dt, and we already know that vx is a omega cos omega t, right? A omega, and the differentiation of cos is negative sign, so it becomes, right? So this is your wx. Similarly, wy is dvy by dt, d by dt of a omega sine omega t, right? Just to confirm, I also show that it is indeed a omega sine omega t, right? Okay. If you differentiate it, this becomes a omega square sine cos omega t, right? Okay. All right. Now we want to find out the angle between v vector and this w vector. You basically need to first find out the cross product, and second divide by product of their magnitudes basically. So this will give us cos theta, where theta is the angle between these two. First of all, we will find out the cross product. So the cross product between v w is nothing but, like, okay, just a sec. Yes, the cross product between v and w is vx I cap vy j cap dot wx I cap wy j cap. Now, as you know, the I cap components can be multiplied. It gives you vx wx plus vy wy. Now what is vx? So vx was a omega cos omega t, right? And wx is, of course, I'll write the minus over here, into a omega square sin omega t, right? And vy is a omega sin omega t, and wy is a omega square cos omega t, right? So if you multiply everything, it gives me a minus a square omega cube sin omega t cos omega t plus a square omega cube sin omega t cos omega t. These two cancel out. Okay, this gives me 0. So basically, and if we divide it by the product of the magnitudes, it will be also 0. So this means cos theta is equal to 0. This means theta is equal to pi by 2 radians. So basically, the conclusion that we can draw from this is, I'll just write it here, when a point moves in a circular path with a constant speed, as in this case, the angle between velocity vector v and acceleration vector w is equal to pi by 2. That is, they are orthogonal. So yeah, so this is basically the conclusion that we can get from this problem. So this is how you solve both the parts. So that's that. Thank you.